if you're collecting a counter movement jump and an isometric mid-thigh pull with your athletes or your clients, then you need to know about the dynamic strength index. It is a simple but very handy ratio that can help guide you with your programming. So here we have the counter movement jump, and that creates a force time curve that looks like this. This is assessing the athlete's peak force capacity in a dynamic movement that utilizes the stretch shortening cycle. Then we have the isometric mid-thigh pull. And if you're not sure about this exercise or this test, then have a look at my video talking about how to conduct an isometric mid-thigh pull test. Here's an example of a force time curve from the isometric mid-thigh pull. As we know, it is an isometric demand, so there's no stretch shortening and just a simple curve here up to the peak force. So to calculate the dynamic strength index, we take the peak force created in the counter movement jump and divide it by the peak force created in the isometric mid-thigh pull. This gives us a ratio that is generally below 1. So if it helps, you can also think of this as a bit of a percentage. What percentage of their strength utilization do they exhibit? So let's take a look at a couple of examples then. And this is taken from my post on the Global Performance Insights blog, all on this topic. I'll pop a link below so you can refer back to that article anytime. So remember that our calculation is the peak force created in the ballistic movement, the counter movement jump, divided by the peak force created during the isometric demand. And so if we take a look at athlete 1, then they are a strong individual. They are generating an isometric peak force value of over 5,000 newtons. Whereas in their counter movement jump, they are creating a peak force of 3,100, giving us a DSI of 0.54. Contrast that with the other two athletes then, who are generally much weaker, creating 2,600, 2,800 newtons of peak force in their isometric demand. The difference between these two is that athlete number 3 is able to create then a higher peak force value in the ballistic movement compared to athlete number 2. Athlete number 3's DSI is 0.93 compared to 0.73 for athlete number 2. So there we have our ratios, regardless of the athlete's body mass, their overall strength or power levels. We've been able for each individual athlete to establish their dynamic strength index. And now research gives us rough thresholds as to help guide our programming based on the DSI. If an athlete's DSI is less than 0.6, then they are recommended to focus on ballistic plyometric type training. However, their DSI is greater than 0.8, they're recommended to focus on maximal strength training. And any ratios in between these values are focusing on concurrent training. Now, in my opinion, the best way to illustrate these thresholds is through these examples. So let's take a look back at those 3 fictional athletes again. As we talked about, athlete number 1 is a very strong individual, creating almost 6,000 newtons of force on the isometric mid-thigh pull. Despite all that strength capacity, that doesn't all seem to be transferring across to in a ballistic dynamic type movement, such as a counter movement jump. They have a relatively low DSI. Again, if we are thinking about this as a percentage, perhaps they're only utilizing 54% of that strength when moving dynamically. That percentage is by no means a perfect figure. That is not brilliant science. It's just a simple way to think about it in your mind. But based on those test results, then this athlete would be recommended to focus on ballistic type training to better utilize the strength that they already have when moving dynamically. As I mentioned, athlete 2 and 3 had relatively similar absolute strength capacities, 2,600 newtons of force against 2,800. However, athlete 3 is better able to maximize those force capacities in a ballistic type movement. Their peak force in the counter movement jump is greater than athlete number 2. So for athlete 3, perhaps a DSI would recommend focusing on increasing that strength capacity through maximum strength type training. Whereas athlete 2 is more balanced, they probably have a need to work on both increasing that strength capacity as well as their ballistic capability. So they would be recommended concurrent training. There are also other exercises that have been utilized to calculate a DSI. Previously, it was quite common to utilize a squat jump rather than a counter movement jump. However, this research from Paul Comfort's group did demonstrate that peak force from a counter movement jump was more reliable than peak force determined through a squat jump. There's a great deal of interest in isometric training and testing at the moment, and so it's not surprising that we've seen different types of tests come to the fore and whether we can utilize these with the DSI. So rather than the isometric mid-thigh pull, some people prefer to use the isometric squat with the barbell on the back. This helps to eliminate grip strength, which can be a limiting factor in isometric mid-thigh pull performance. Also, there's growing popularity with an isometric belt squat. Here is an example kindly provided by Lucas Galmiche from Vowed Performance. But the question remains whether we can plug this into our DSI calculation and how our thresholds might be changed, because the athletes can potentially create a much higher peak force output in the belt squat compared to the isometric mid-thigh pull. So here we have some data from Lucas at Vowed, and in this mini study of 16 healthy subjects, they were able to create nearly 50% higher peak force production in the belt squat compared to the isometric mid-thigh pull. This is early research into this topic, but is similar to some of the data that I've also seen collected. So with this difference in isometric force capacity in mind, we would need to shift our threshold. And in this case, Lucas suggests that that would then align to 0.4 and 0.6, as opposed to 0.6 and 0.8 with the isometric mid-thigh pull. But it's early days, and so if anyone has some research, either published or perhaps internal data that they're able to collect with their athletes, comparing the force outputs from a mid-thigh pull with a belt squat, then please share, please get in touch, because this will be really valuable information.
ForceDex, the world's fastest, easiest, and most powerful dual force plate system. Assess physical performance in seconds. Jump, land, squat, push, pull, and more. ForceDex automatically analyzes more than 20 common tests. You can even record video, which is automatically synced with your force data. Then find all your data and reports in one place, VoldHub, including integrated norms based on millions of data points, helping give context to your athletes' results. And it's not just ForceDex. You'll find all your Vold data in VoldHub. One login, all of your performance data. Welcome to Vold.
Let's now talk about some of the important practical considerations for calculating the DSI in the real world setting, because I'm all about blending science and the research with practical applications in the real world, which if that's what you value as well, then please subscribe to the channel so you can see more of my Sports Science Insights videos. So an important consideration is that an isometric mid-thigh pull or a similar isometric test can potentiate your athletes, which could help their counter movement jump performance. So I like to approach this by always conducting the counter movement jump first. If you want to be able to compare your athletes over time, then I'd recommend doing the counter movement jump first, because then it doesn't matter if it's a day when you're then collecting an isometric mid-thigh pull or not. You're not going to have that confounding factor of a potentiated athlete doing a counter movement jump. The grip can make a big difference on the isometric mid-thigh pull. And as we already talked about, that is why the belt squat is becoming a really interesting and potentially popular test in the applied setting. But if you're sticking with the isometric mid-thigh pull for now, be aware that both chalk and straps can help the athletes in this test. So you want to have a consistent approach. Either you allow your athletes to use these tools or not. Familiarization can be a big piece, particularly with the isometric mid-thigh pull. So make sure your athletes are used to doing this kind of a movement. Counter movement jump tends to be a bit more natural. Of course, generally the focus is more on making them familiar with an isometric mid-thigh pull. And of course, although this ratio can guide us with our programming, it does not mean that you solely focus on that one single type of training, that you allow the DSI to absolutely guide everything within your programming. Like everything, like every test we talked about should be part of a battery of tests that you are combining with your objective information and also your subjective coach's eye about the athlete's physical capacities, both on the field, but also then in the weight room. Because we have to be cautious. There are limitations with ratios and there are mathematical concerns with just making this such a simplified calculation. So Look at their performance in a counter movement jump. Look at their performance in the isometric mid-thigh pull. Use the DSI, but use it all as part of a mixture of data and observations to determine how best to support your athletes. If you like this video, then definitely check out the rest of my athlete testing series sponsored by Valve Performance.